Welcome to the Explainer. If you're a Python developer, you know the feeling, right? Your script is humming along just fine, everything's going great, and then, bam, it just crashes. Well, today we're going to dig into those crashes, what we call errors and exceptions, and I'll show you how to turn that roadblock into a tool that actually makes your code stronger.
Okay, if you've ever touched Python, I guarantee you've seen this. This wall of red text. It's called a traceback. And yeah, it can look pretty scary. But here's the thing we're going to learn today. It's not just a sign of failure. It's a roadmap. It literally tells you exactly where things went sideways and why. We're going to learn how to read.
All right, let's get right into it. The first thing we need to wrap our heads around is that there are really two different kinds of problems you'll run into. They might look the same at first glance, but Python sees them in completely different ways.
So on one side, you've got syntax errors. Think of these as just bad grammar. You forgot a parentheses, maybe you misspelled a keyword. It's like writing a sentence that just doesn't make sense. Python can't even start to run the code because the rules are broken. But then you have exceptions. This is different. The code's grammar is perfect. It's syntactically valid. But when it's running, it hits a situation that's just impossible. Like, trying to divide by 0 or find a file that isn't there. And that's what we're really going to focus on.
So the big question is, how do we stop our programs from just face-planting every single time one of these exceptions pops up? Look, we can't prevent every single error from happening, but what we can do is anticipate them. It's time to learn how to build some defenses into our code. And that's where this whole idea of exception handling comes into play. Honestly, this is a core skill for building apps that are actually robust and professional. Instead of just letting an error torpedo the whole thing, we're going to build in a plan B, a controlled, graceful way to deal with a problem and let the program keep on chugging along.
Okay, let's look at a real example. This piece of code. It's perfectly good Python. It's telling the computer, hey, go open this file and read what's inside. Simple enough. But what if that file just doesn't exist? Well, the program hits a brick wall. It immediately throws what's called a file not found error and just stops dead. Game over. But now watch this. This is the magic. We take that exact same risky code and we wrap it in something called a try block. We're basically telling Python, hey, try to do this, but just a heads up, it might not work. And right after that, we add an except block. This is our safety net. We've anticipated the problem and given the program a clean escape hatch instead of just letting it crash and burn. Now, this is absolutely crucial. This is the golden rule right here. You have got to be specific. I know it's super tempting to just write a bare except that catches everything. Don't do it. It's so dangerous. It's like telling your program, hey, if anything goes wrong, just pretend it didn't happen. You're essentially putting a blindfold on. You'll hide every single error, making debugging an absolute nightmare. Always, always name the specific exception you're looking for. You can even list a few of them in a tuple if you need to.
Okay, so the basic try except is awesome. It gets you really far, but we can get even more fine-grained control. Python actually gives us a couple more pieces to add to our toolkit for when things get a little more complicated.
So we already know about try, that's for our risky code, and except, which is our plan for when things go wrong. But check this out. There's also an else clause. This is the success code. It only runs if the try block finished without any problems at all. And then there's the real MVP, finally. Think of finally as your cleanup crew. It runs no matter what. I mean it. Success, failure, finally always gets the last word.
Let's visualize this flow, because it's like a little decision tree for your code. Python starts in the try block. Does an error happen? Okay, it jumps over to except. No error? Great, it moves on to the else block. But look at that final step. No matter which path it took, the error path or the success path, it always ends up in the finally block. That guarantee is what makes it so incredibly useful for stuff you absolutely have to do, like closing a file.
All right, up to now, we've basically been playing defense, right? We've been catching errors that Python throws at us. But to really master this, we have to go on the offense. That means learning how to create and throw our own errors, our own exceptions to enforce the specific rules of our own applications.
And that leads to a really important question. Why would you even do that? I mean, Python already has tons of built-in exceptions. Why make your own?
Well, the answer really gets to the heart of what separates a simple script from a truly professional piece of software. You do it when you need to flag an error that's unique to your program's logic. And the tool we use for this is the raise keyword. It's super simple. It lets us manually trigger an exception on our own terms whenever a certain condition is met. So if a user enters some data that's technically valid but breaks one of your application's rules, you can raise your own error to say, nope, that's not right, and here's why. So how do you choose which to use? The rule of thumb is pretty simple. For general problems, stick with what Python gives you. Value error for bad data, type error for the wrong kind of object. That stuff is universal. But when you have an error that is all about your application's specific rules, an invalid email format or a grade outside a specific range, that's when you create a custom exception. It makes your code 1,000 times clearer.
And creating one is ridiculously easy. Seriously, look at this. You just define a new class, and you have it inherit from Python's main exception class. A lot of the time, that's it. You just need the pass statement. The real magic isn't in the code inside the class, it's in the name of the class itself. Grade value error tells you so much more than a generic value error. It's self-documenting code. Okay, let's pull all these threads together now and look at how we level up to pro-level error handling. These are the practices that make sure your app isn't just, working. They make it truly reliable and something you can actually maintain long-term.
So here's a big one. Instead of just printing errors out to the screen, where they just disappear forever once the program closes, professionals log them. Logging gives you a permanent record of what happened, especially the errors. The analogy is perfect. It's like the black box flight recorder for your application. When something goes wrong in the real world, you can go back and look at the logs to figure out exactly what happened. And getting this set up is super easy. You just import Python's built-in logging module. Then, inside your except block, instead of a print statement, you just call logger.exception. The cool thing is, this doesn't just save the error message. It saves the entire traceback, that whole wall of red text, so you have all the context you need to squash that bug.
But what if one error causes another error? This happens all the time in complex apps. For that, Python gives us an amazing tool, exception chaining. You can literally say, raise new error from original error. And when you do that, the traceback shows both exceptions linked together with this exact message. It's so powerful for tracing a problem back to its root cause.
So let's wrap this all up. Think of this as your new checklist for writing rock-solid Python code. Be specific, don't use a bare except. Make your error messages actually helpful. Use finally for your critical cleanup. Document the kinds of exceptions your code might throw, and use raise from to chain exceptions and give yourself the full story. This is the blueprint for resilience. So I'll leave you with this final question to think about for your own projects. It's easy to write code that runs just fine on a sunny day when everything goes perfectly. But what happens when the storm hits? The real mark of an expert developer isn't writing code that just works. It's writing code that anticipates failure, that handles it with grace, and that knows how to recover. So ask yourself, is your code just working, or is it truly robust?